Okay, so we saw that if you had nice laminar streamlined flow, Poiseuille's law told you how much volume per time would flow through a pipe. But how do you know when you're going to have a nice laminar flow? What determines when this thing becomes chaotic? What determines when these start to cross, these layers of flowing water or fluid? How do you know when they're going to start to cross, which is going to cause these vortices and eddy currents? When will this happen? Turns out there's a way to predict it. It's hard. This is very hard, in fact. Not only is it hard to predict it, once you know that it's going to happen, once you know things are going to become turbulent, it's even harder to try to describe the behavior. Typically, you have to resort to a computer simulation rather than an analytical calculation. But there is a number. It's called the Reynolds number. And what this number does is it gives you a way to predict what's the first speed. What's the critical speed? Where if you went over this speed, if the fluid were to flow faster than this speed, it would become turbulent. The flow would become chaotic. The way you find it is you take this Reynolds number, I'm going to call that R, you multiply that by the viscosity, and remember eta, this Greek letter we were using for the viscosity. You divide by 2 times the density of the fluid, multiplied by the radius of the tube. And this gives you the first speed where you would expect turbulence. Now, if you measure the Reynolds number, to give you an idea, for blood, because this comes up a lot when you're talking about blood flow in the aorta, you might worry that there might be turbulence. For blood, the Reynolds number is around 2,000, and it's unitless. It has no dimensions. There's no units here. All the units cancel out. And the Reynolds number is a unitless, dimensionless quantity. So knowing the Reynolds number gives you a way to predict what's the first speed where you might expect turbulence, and therefore the first speed where you might expect Poiseuille's law to not give you an accurate description of the flow of the fluid.